We're cooking? Okay. So the first thing you're going to do is, it's going to look very much like what we did yesterday. It's going to have a differential equation, so there's going to be a derivative, there's going to be an x, there's going to be a y. So if you look at this guy, this is what we did yesterday. dy over dx is equal to x plus y. The difference is that is not a separable differential equation. That is something I could not do yesterday. But that's okay, because you can do it with slope fields. So what is a slope field? Some books call it slope fields. The AP calls it slope fields, so that's what we're going to call it. Some books call it a directional field. But essentially, all of these little tick marks are the slopes at each of those individual points. So it's really, really easy, because all you do is you plug and chug, let's say 0, 0. If I were to plug and chug and I want to find the slope at 0, 0, would you all agree that the slope at 0, 0 would be 0?
Yeah.
Because 0 plus 0 is 0. Do we agree with that?
Yeah.
Well, how would I represent the slope of being 0? It's a horizontal line, right? So notice you can barely see it, but it's there. It's a straight horizontal line. Let's go to 2, 0. This one is a little bit more obvious. If I am at 2, 0, when I go to plug and chug, what's the slope going to be? 2. Well, the slope of 2 is positive and a little bit steeper than 1. And so if you see it, there is the slope that is 2. Do we see that? So all of these tick marks are representing the slope of your differential equation, from your differential equation, at those specific points. Okay? So on the AP exam, they could ask you to sketch a slope field. It will not be this many points. Okay? I've never seen them do more than 9 or 12. But they may also ask you to sketch it and to draw an actual solution to it. And so what do? They'll tell you a specific point that they want you to draw a solution through. So if it was 0, 1, you're going to go and put your point there. And you are going to follow the curve of these tick marks. So you would not go down, right? Do you see how these tick marks are all kind of leading me upwards? So it's kind of like waves, if you will. This is shooting me upwards, so that's why it should go up, not down. So now, do you see how my tick marks, what are my tick marks telling me to do? Go flat, right? Maybe have like a minimum. And what are once I do that, what's my tick marks telling me to do? Go back up. Do we understand that?
Yep.
Okay? So these tick marks can also help us to actually get a solution that passes through a point. Kind of like what we did yesterday. We're just graphing it today versus solving it algebraically. All right, so following your guided notes, right underneath, I have a very long and tedious table. But they've given me a differential equation that looks like this. And they want us to find the slopes. Well, if my point is negative 2, 0, what is the slope at negative 2, 0? 3. What is the slope at negative 1, 0? 0. What is the slope at 0, 0? What's the slope at 1, 0? 2, 0? Negative 2, 1? How about negative 1, 1? How about 0, 1? 0. How about 1, 1? And 2, 1? Oops, I was about to put 3. Is it 4? 2 squared is 4, plus 1 is 5. Yeah, so it's 4, right?
Yes.
All right. You all have it on the same slide, like right underneath it. I don't. I've got to move on. But these tick marks should correspond with my table. If I look at 0, 0, what did you all write down that 0, 0 had a slope of? Negative 1. Is that a negative 1-ish slope? Yes. So the big question students ask me is, okay, how specific and how accurate does a -1 have to be? Are they going to pull out a ruler and say, nope, that's not 45 degrees? No, they will not on the AP exam. But if you are having to draw -1, do you draw it like this? No, you draw it like this. If you were going -2, be conscious of the fact that it needs to be a little bit steeper than your -1, okay? They need to see that general wave correct. They will give you the points, no problem, okay? All right, let's pick another one. What was happening at 1, 0? Sorry, 0, 1. Was my slope 0? You see how it's a nice little horizontal line, okay? If I was at 2, 0, I think we did 2, 0, what was my slope?
3.
You see how steep this guy is versus the guy that we had at 0, okay? Any questions? So all of these tally marks are based off of the slope from that differential equation. That's it. That's pretty much the gist of the lesson. So let's talk about drawing something. So if they ask me to actually sketch a solution through the origin, then can we agree that my general waves are telling me that it needs to be some kind of like an x cubed? Do we agree with that? Okay? So you could draw based off of the curves. And of course, the more curves you do, the more tick marks you do, the more accurate it looks. Okay? Like I said, this is too time consuming. So the AP will never ask you to do this. That is ridiculous. Okay? They will only ask you to do maybe about 9, maybe 12 tick marks, if that. Okay? Yes?
So it says the point is 1, 0, but is that, why does it not correspond?
Where did it say 1, 0?
On the chart?
1, 0
Yeah.
was 0. So was that not it? At 1, 0, yeah, we're cooking. It's flat.
But like, why do you draw the curve not on 1, 0?
Oh, gotcha. Okay, you're talking about this dude.
Yeah.
Yeah. So if, and it didn't specify, but I'm assuming it's going to cross through 0, 0. Let me go to this one. This one's not drawn. Do you see how my slope is this way?
Yeah.
So it's throwing me to do this, right? What are my curves telling me to do now? To kind of curve down, right?
So the points are for, I don't even know. What
Oh,
is
so
the
the dx equals 0, right?
You just have to
And
find
then
the
the
slope of
is
the points on the
0, it's
field.
gonna be
It's just finding the slope of that point.
But
It's
that
not really
point-
just saying that
That
you're
point
gonna
is not
go
on the
through
line.
it. If you were going, like, if you started at a different point, you might actually hit it, but
If dx equals 0, it's either going to be a maximum or a minimum. It's not going to necessarily cross with it.
Because it's like when you do those dx where you have to add the plus c where it can change by a constant.
So what Brianna's telling you
Are the X and Y points for the derivative?
is right here. The X and Y values, are you talking about the X and Y values like in my chart?
Yeah.
The X and Y values are the guys that you plug into your differential equation.
So they're not for the function, but for the derivative. Or no?
They are for your function.
Are they points of the function?
They kind of are.
Yeah.
Because this drawing is actually of your function. But like Brianna said, there are many functions that have the same derivative, right? We've talked about that, like the
Yeah.
plus c that she's talking
Yeah.
about. These 3 graphs that you see, actually 4 graphs, I feel like I see one here. There's 1, 2, 3, 4. These are all the same graph plus c
Right.
that have the same derivatives. That was that dy dx from up above. Does that make sense?
Yeah. The points are kind of throwing me off.
So the points are of the function and the derivative essentially. You're finding at a specific point what is the derivative going to be at that specific point.
Right.
it doesn't really relate to the graph that you draw, though. Is what she's trying to say.
It'll help you with the curvature of the curve you're drawing.
Yeah.
Does that make sense?
So what are the points from? Or
I'm making the points up. I mean,
Oh.
so we're gonna draw some. So this is now on the back, I think. So like Xander,
Yeah.
I have a clean slate. And on the AP, if they put this on your free response,
Yeah, I guess if we do
Let's
an
see.
example, I understand better.
no, let me pull up the other one. Let me see if this one works. See, on the AP, they're gonna give you a blank slate. You see how they have little dots here? And they're gonna ask you to sketch a slope field given this particular differential equation. So you're gonna fill up this sketch with the little tick marks. That's what we're about to do right now. And the points, here I've got a whole plethora I could pick from. On the AP exam, you're gonna pick specific, they're gonna be very specific about what points they want you to pick. So like here, it specifically said between -1 and 1, and they want you to do those 12 points. So they'll be specific as to what points to pick, because you're saying you're confused about the points?
Yeah, so the points don't, yeah, I think I understand. I think if we do
So
an
let's do one.
example, yeah.
Let's do, so I've got a whole bunch of points to pick from. Let's pick some easy ones.
0, 0.
Yeah, 0, 0. Bring it on. What's happening at 0, 0? What's my slope? 1.
And it'll be 1 for all of them.
Oh, not all of them.
I mean, like, on
All the
for
Ys.
All the-
So, so if I pick 0, 1, what's my slope?
1.
yeah.
If I pick 0, 2, what's my slope?
Still 1.
Yeah. Do we get the idea of what Xander said? They'll all be 1 because is there a y as part of my differential equation? No. So whatever my x is, no matter what my y is, will always be 1. Do we agree with that?
Yeah.
Okay. All right, let's pick 1, 0. How about that? If I pick 1, 0, my slope is 2. Notice I'm going to go a little bit steeper. And if I pick 1, 1, what's my slope still?
2.
And I think we get the point. I probably went too steep there. That's okay. All right. Let's go this way. Let's go -1, 0. What's happening at -1, 0?
0.
Oh. Our slope is 0. So we're going to represent it with a straight horizontal line. So what happens at -1, 1?
Still 0.
Yeah. So can we agree that all of these are 0? Okay. Let's go to -2, 0. If I go to -2, 0, what's my slope? -1. And so they're all going to be -1, aren't they? And if I go to -3, 0, it's going to be -2, and that means they're all going to be -2. All right, Xander, I'm going to really try my best to see if I can make it happen here. What curvature do you see here on these tick marks? Yeah. So, can we agree we have like a family of parabolas here?
Yeah.
When I derive a parabola, what do I get? What? A line. What's my derivative?
A line. Whoa.
What?
Oh,
So fancy.
it makes sense.
So, what have I drawn here? What graphs, what solutions am I looking at? They are like my integral, yes.
Oh my god.
So what we did yesterday was we algebraically solved this, right? That was what we did yesterday. We algebraically solved this for y equals. I am now getting a family of solutions to that particular differential equation. Yes, Mr. Reese.
So do all the family members basically change because of the C?
Yes!
Hooray.
Yes. Does that make sense?
Mm-hmm.
Do we understand that?
Yes.
Okay? All right. So some of them are not going to be this pretty, right? This was a very obvious one, which is why I like to start there. We have 2y. That's not going to be something we we know what that is, right? It's 2y. That is not a line per se. We don't know what the heck is going on there. So it's not going to be as obvious. But let's think about this. Okay. We have 2y. Let's think about what our slope field is going to look like.